Okay, so today we're looking at question 496, next greater element 1. The next greater element of some element x is an array. In an array is the first greater element to the right of x in the same array. You are given two distinct zero-index arrays, nums1, nums2. Nums2 is a subset of nums1. For each I between 0 to nums1 length, find the index j such that nums1 at index I is equals to nums2 at index j, and determine the next greater element nums2j at index j in nums2. There's no greater element, then the answer is -1. So we're supposed to return an array of answers of length nums1.length such that the answer at index I is the next greater element as described above. Okay, that's a lot. So let's just look at an example, the example 1 here. How do I shift this thing? There we go. Okay, so we have nums1. Oh, wait a minute. How do I... Okay, you know what? I'm gonna shift this back and I will switch screen to a nicer looking, more aesthetic background. Because apparently it helps with learning and problem solving, I think. Nums1, 4, 1, 2, nums2, 1, 3, 4, 2. Okay, so given these arrays, what we want to do is basically we see element 4, we look at the element 4 in nums2, and we see if there is any larger elements to the right of this number. So 4 to the right, there's no more numbers bigger than 4, so we put in our result array -1. Next we look at number 1. We see that for number 1, there is one element, there's two elements greater than it, but the immediate right element that's greater than 1 is 3. So we put there 3. And lastly, for number 2, we can see that there's no more elements to the right of 2. So we again do -1. In the end, we return the array -1, 3, and -1. Let's check our answer. Okay, looks correct. So how can we solve this? We are going to construct a dictionary where we traverse through nums2 once to figure out what is the pairings for each of the numbers in nums2. So we construct something like this dictionary, construct something like 1. The rightmost one is 3, and then 3, the rightmost one is 4. 4, there isn't any, so we can either put it into the dictionary or just not even bother with it. So let's not bother with it. And 2, there's no more rightmost element, so we end off with this temporary dictionary. And then taking this dictionary, we can traverse through nums1 array, and then we check, 4, there isn't a key in this dictionary, right? So we put -1 there. 1 has like a the key one has the value 3, so we put there 3. And then lastly, 2 doesn't exist in the dictionary, again, -1. So how do we construct this, what do you call it, pairing, right? We can do something like have a temporary stack, and then we start pushing things onto it. And when we find out that there is a larger element, we can pop it off the stack, right? So we push 1 first, and then we compare 3 and 1, and we see that 3 is larger than 1, so we have found the, wait, is it strictly larger? Let's check. Greater than, right? Okay. Okay, so there will not be any repeated numbers. All numbers in the arrays are unique. Let's push 1 on, and then we find that 3 is larger, so we do not we pop it off, and we found the pairing for 3. And then remember that we need to do the same for, and then we push 3 onto the stack. And since 4 is larger than 3, we do the same thing for 3, and then we push 4 onto the stack. 4, there's 2 is smaller than 4, so we don't do the popping thing, and we push it on, and that's the last element to be examined with our stack, so-called. So let's try another example of, say, maybe 2, 1, 3, 4. Let's say this, right? So the answer for this should be something like 2 goes with 3, 1 goes with 3, 3 goes with 4, and 4 goes with nothing. Am I right? Yeah, I think so. Okay. So again, let's try with this stack. Push 2 on. 1 is smaller, so we can how do you say this? We can continue pushing it onto the stack. Okay, that's fine. And now we're looking at 3. 3 is bigger than 1, so popping 3 off and then pairing it with 3. And again, we look at our next element, 2. 2 is also smaller than 3, so we continue popping 2 off the stack. And then comparing with, finally, stack is empty, we push 3 onto the stack. Now we're examining 4. 4 is again bigger than 3, so we pop 3 off and then pair it with 4. Okay, so now onto the code. Clear this board. There's a few things that we need, right? Number 1 is the temporary dictionary. Oh, what's going on? Temp stack first. Oh, what's going on with the indentation? This is really weird. Let me refresh the page. Okay, the indentation is really weird, but let's just try again. Stack. Oh, okay, it's fixed now. Temp dictionary. We have a temporary dictionary. Okay, so now we start off by traversing nums2 array first. For I in nums2. Oh, hang on. while stack and stack's topmost element is we want it to be we can continue pushing it if it's smaller than, so we want larger than, right? Larger than the topmost element if it is large. Wait, is it larger than? No. If it's smaller than the element that we're looking at, then we do the popping, right? Okay, this is confusing to me. Like the larger, and when it comes to larger and smaller than it, yeah. Okay, so then what we do is we popped num is maybe I should just name this stack instead. Pop num is stack dot pop. Now we have the pop number. And then what we can do is once we pop it off the stack, what we want to do is assign that to as key to the dictionary to our current I. Yes. Temp dict popped num is a I. Okay, so we've done our popping, and then at the end of it we do stack dot append our I. So at the end of this, we should have our temporary dictionary of pairs, and then for num in nums1, we traverse through it, and then if num in temp dict, if it can be found in the temporary dictionary, it means that there is a greater element. Then we we have to have a resultant array as well, right? Can we modify it? Let's just modify it. I think it's fine to modify it. Yeah. Nums1 okay, let's do by index. For I in range length nums1, if nums1 I in temp dict, if it's in the dictionary, that means there is a pair. So we want to write it to I. We want to assign it the value of temp dict nums1 I, else one at this position we want to assign it -1. Okay, in the end we return nums1. Let's try this code. Okay. Okay, great. So thank you for watching this video.